name's Wes. I'm from Canada, which is why I say JavaScript and not, I don't know, how do you all say it? JavaScript. It's wrong. Their whole country has it wrong. The slides are going to have a lot of examples on it today, so I'm going to tweet the link out shortly, sometime after today. So I'm at Wes Bos on Twitter. So I make training courses. I try to make JavaScript and CSS and web development easy to understand for people. So I've got one on ES6, one on React, one on Node. I just released a couple months ago one on CSS Grid. It's a free one out at cssgrid.io. Anyone taking the CSS Grid one? A couple of people, awesome. I have a podcast called Syntax, which is sort of a weekly podcast where we try to provide some tasty treats, which is value, I guess. And today I'm here to talk to you about JavaScript. Now I'm going to be thinking about how I say JavaScript every single time. JavaScript is always evolving. We've had ES6, which was a massive, massive update to the language. It was sort of just years and years of things that were supposed to be coming to the language, and then once ES6 was released, we had this massive update to the language. And we also had ES 2016 or ES7, we had ES8. We've got a whole bunch of new DOM APIs, which is outside of what the ES whatever things are. So in this talk, what I'm hoping to do is to introduce to you, I don't know, a handful of different new APIs that are either coming or already in JavaScript, so you can help yourself build better stuff throughout your job. So if you're ready, it's going to be a lot of information. Hopefully we can get through in 40 minutes. Let's get into it. So first I want to talk about promises. And the promises are not brand new, but part of what I want to talk about today is something called async await. And this is all built on top of promises. So quick show of hands, how many of you are using promises in your JavaScript today? Cool, about half of you. So I'm going to do a quick review of it. Promises are sort of like an IOU for something that's going to happen in the future. This might be an AJAX call that's going to return data at some point in time. This might be getting access to a user's webcam or access to the geolocation of your user. This might be resizing an image. All of those things, they take time, right? And with a promise, we simply kick off the process and move along with our lives. We don't sort of sit there and wait for it to finish. We keep going with other stuff, and when that data comes back, when those permissions are allowed, then we can come back and deal with them accordingly. So the question is, like, why do we do it this way in JavaScript? And that's because JavaScript waits for no one. That's what I like to say. Almost everything in JavaScript is asynchronous. And I'm going to sort of try to explain that through some stupid examples that I have here. So let's say we wanted to do a couple things. You want to make coffee, you want to drink coffee, you want to cook breakfast, and you want to eat breakfast, right? Those are some things you might want to do in the morning. Do you need to finish making coffee before you can even start breakfast? Which I realize is probably not a good example because some people said, yes, I do need to finish my coffee before I can do anything else. So you are very much a synchronous coffee drinker. But would it make sense to wait until the coffee is made and consumed before you even start cooking breakfast? And the answer to that is no. We want to start one thing, put on the coffee, move along with other things that are in our morning, like cooking breakfast. And when the coffee is done, you come back to it and you drink it and you put it in your cup and you do everything that you do with coffee. So here is some code in promises that it might look like this. We have a function called make coffee. We'll have a function called make breakfast. And those will return not coffee and breakfast. They will return an IOU, a promise that coffee will come at some point. A promise that breakfast will come back at some point. And the way that we listen for those things to come back is with the then keyword. You chain a dot then onto the end, and when the coffee comes back, when the breakfast and the eggs and the bacon come back, then you can deal with them by drinking them or eating them. You can also wrap them in a promise.all, which is sort of like a mega promise, where you take two other promises, you put them into one mega promise, and you can wait for both of those things to be done. So if the coffee takes 5 minutes longer than the breakfast, you will not sit down with coffee and breakfast until both of them come back. So that's kind of the gist of promises. Most new browser APIs that are being built on in the browser are either being built on promises or observables, and I'll talk a little bit more about observables in just a second. So best example is fetch. Fetch is sort of like a jQuery $.get JSON. but it's for doing AJAX requests, nice and small in a little bit of code. So here I've got cooldogs.org, I fetch it, that comes back with some data, we convert that data to JSON, and then finally we get a bunch of dogs that come back from that API endpoint. I really like to use a library called Axios, which is sort of like fetch, but has some really nice defaults where you don't have that double then in it, where you can just go ahead and grab your data. Many more. Payment request API, Getusermedia, web animation API. All of these things are being built on standard promises, which means that we can sort of like use them together because they're all built on sort of a standard promise API. It's really easy to make your own promises as well. So here's an example where I make a function called sleep, takes in an amount that you would like to sleep, and it will return either after however many seconds you pass it. Let's say I pass in 1,000 milliseconds. After 1 second, it's going to resolve, meaning it's going to, that IOU that we talked about earlier, it's going to complete itself. Or you can also reject, meaning something went wrong inside of that promise. Maybe there was a network error, or maybe that amount was just too little, it was less than 300 milliseconds, and you can reject from that. So that's basically how you have a promise is, it's a function that immediately returns a promise, but then at some point in the future, it resolves with either a data or just some success. So this is a little bit of what it looks like. Kind of the nice thing about promises is that it allows you to chain them one after another. So if you call off your first promise-based function, sleep, it allows you to chain then on it as long as you could possibly want. So it allows you to do sort of sequential code without the, well, let's talk about it, without the Christmas tree callback help. We've all written some terrible code. I've probably written more terrible code than most of you, but I've written much code that looks like this, where you make breakfast. When that's done, you have a callback. And then that is, you make coffee. And when that's done, you eat breakfast. And when that's done, you drink your coffee. And when that's done, you clean up, right? That's very sequential, all callback based. And sometimes that's not necessarily what we want to do when we're writing our things. So here's another example with promises. If you're writing some sort of very simple animation library where you're moving to X and Y coordinates, previously we would have a callback as the last argument of the function. And when that's done, you would run another one. And when that's done, you would run another one. And you sort of get a whole bunch of these, I like to call them winking, frowning neckbeards, because you just get a whole bunch of them. And usually about 2:30 on a Friday afternoon, you delete one of them by accident, and then your weekend is ruined because you can't figure out where the freaking closing bracket is missing. So promises help you a little bit out with that, where you can chain then, one after another, and you get away from that Christmas tree callback hell code. It looks like a Christmas tree if you turn it sideways, that's why they call it that. So we get it. Promises are great, but then it's still kind of callbacky, right? Like, you still have one callback, and then all of your other code comes after it. So with promises, any code that needs to come after the final promise still needs to be inside of the final .then callback. So anything that is after the final promise code, you ran 3 or 4 promises, it all goes inside of the final .then, and that doesn't look great, it doesn't read super well. So that's where async await comes in. Async await is still based on promises, but it's just a really nice syntax that allows you to work with promise-based functions. So here's our simple example where we had a callback hell, we converted it to move to with promises. Pretty good. But with async await, what it allows us to do is you can mark your function as async, and then inside of that, it allows us to use this await keyword, which will allow us to sort of pause that function from running. It's not going to stop all the other JavaScript on your page from running, which is why it's called await, asynchronous wait, meaning it's not wait everything, don't pause everything on the page, but just pause this one function temporarily until that function resolves itself, and then we move on to the next line of code, and the next line of code until all of those are resolved. So let's break down how async await works. I talked to you earlier about JavaScript is almost entirely asynchronous, or non-blocking, we like to say. And that's great because it allows us to write applications where you don't necessarily freeze up other parts of your UI. There's actually a couple things in JavaScript that are synchronous and blocking, and good examples of them are prompt, alert, and confirm. Have you ever noticed when you try to prompt, I don't know if you use prompts anymore, but if you use a prompt, everything else on the page will sort of freeze up. And that's not great, but it's nice because you can just say like var name equals prompt what is your name, and then immediately the line after you can get that variable because it will run synchronously top to bottom. So here's a little bit of PHP code where this is kind of maybe what you want to do, where you want to fetch 2 users from a GitHub API. So I'll make a variable called Wes. I'll use something like file get contents and put that into the Wes variable. I make a variable called Scott. I do the same thing. Finally, the 2 lines after that, once those 2 have completed, then I have the data, and I'm able to go ahead and use it, right? That reads really nicely because you can just read it top to bottom, and there's no callbacks or promises or then or anything like that. It just reads top to bottom, and it makes sense, right? With JavaScript, it would look a little bit something like this. You fire off your 2 axios.gets. Both of those will return a promise. Then what we do is we wrap that in a promise.all, which will make a mega promise. And a mega promise, once both of them come back, one of them takes 12 seconds, or no, 12 seconds, 12 milliseconds. The other one takes 2 seconds. It will wait the full 2 seconds. And then we chain a dot then onto the end, and we have both pieces of that data. So that leaves me kind of feeling like, the PHP is easier to read, top to bottom. The JavaScript is much more performant because, like, look at this. This right here, the Wes file get contents, that waits until it's finished before the next line is run. And that's unnecessary. Why do I have to wait for Wes to be done to fire off the second request, which is Scott? That's going to result in slow applications, right? So with async await, what we do is we get synchronous looking code, but without the actual wait of doing that PHP code that we were looking at. So let's look at how it works. First thing you do is you mark your function as async. So you still keep all of your existing promise-based functions. So your function sleep, that's still the same one we wrote earlier. It still returns a promise. There's nothing special you need to do to your functions that return promises to use async await. But when you go in to use it, you mark your function as async with the keyword async in front of it. And then, second thing we do is you can use the await keyword inside of your asynchronous function. So here we have our sync function go, and then inside of it, you can just start to await a function called sleep, which returns a promise, and that will sort of pause that from running. And here you have the option of, you can either just await a function, and then when it resolves, you can go on to the next line, or if there's some sort of data coming back from that promise that you're interested in keeping, you can stick it in a variable by doing this, and that is not going to put the response is not going to be a promise. Response is going to be the actual data that gets resolved at the end of the day. So really, it's the best of both worlds. Let's look at another example. Here's like a slow example. This is the equivalent of that PHP example we looked at in JavaScript, where I'm awaiting Wes to come back before we go into Scott. And it looks good because it reads top to bottom, get your data, use your data. There's no weird callbacks inside of it. But why are we waiting for Wes when both of those should be fired off at the same time? If you have 4 or 5 requests and they have nothing to do with each other, you should fire them all off at the exact same time and wait for all 5 to come back. So here's what we do. We stick those promises into variables. We wrap it in a promise.all, and promise.all will resolve the data into an array, so we can use this ES6 destructuring to put that data directly back into variables called Wes and Scott. Really nice, no callbacks or any then promises that we have there. Error handling is, there's one thing that we didn't show here, which is what happens if there's an error. There's no catch. There's no any way to really handle this error. So I've got a video up on YouTube. I don't have time to show you all of it today, but there's about 4 or 5 really nice ways that you can handle errors in async await not just a try-catch that maybe you have seen online. So that's async await. I'm really excited about it. It's been a long time since I've had something just fundamentally change the way that I write my code. So if you haven't looked into using it, I would highly recommend it. Next up, I want to talk about something called Intersection Observer. So I told you like the promises are a really big thing, but some new browser APIs are built on what are called observers or observables. So the question we have here is, how do you know when an element is on the screen? How do you know when something is sort of showing on the screen, when something is scrolled into view? So here is, I wish that Val would help me out with my animations, because this sucks, but imagine that this viewport was your computer screen, and imagine the dogs was like dogs.net, and you're scrolling, and you want to know what dogs are currently partially or fully into view. Well, how would you do that right now? You would listen for a window scroll, and you would loop over every single image, and you'd figure out the like offset values and subtract it from the height of the screen, and you'd figure out if that thing is technically on screen or not. So with Intersection Observer, it's going to be much easier. We can be alerted when an element is fully or partially scrolled into or out of view. So a couple of use cases for this, if you want to animate elements in on scroll, so you kind of get that kind of fancy where you, as soon as you scroll it, it comes in from the sides, or if you wanted to play a video when you start to scroll in, although browser APIs are now changing where that's not allowed anymore. If you want to lazy load images, don't actually fire off the request until the first pixel of that image makes it onto screen, and then fire off the actual request. You can record views for ads beyond the fold. You want to know how many people are actually making it to lower to see your ads or pieces of your website. You can use Intersection Observer to do that. You can use it with sticky headers. So here's an example with some pigs where as soon as you scroll into view, what I'm doing is I'm adding a class of scrolled in or something like that, and then you can use CSS to animate the translate X value, and then when they scroll out of view, you just remove that class, and then the CSS will do the opposite. Here's another good example from Google developers with sticky headers. So we're also in CSS getting this position sticky, and it works really well with the Intersection Observer. I don't know if you remember, like the first iPhone had this in your address book. It's pretty nifty. So are you ready for some meta? And I thought like, oh, this Intersection Observer is really cool. And while I was developing the slides for this talk, I was like, okay, I'm writing about Intersection Observer. Now, how could I tell if my video was in view so I could autoplay the video? And I thought, oh, I can use Intersection Observer, meaning that like I have these videos right here, and it autoplays as soon as my slide comes onto the screen, and then as soon as I slide away, I want the video to pause because I don't want it to be running in the background, consuming bandwidth or consuming CPU cycles when it shouldn't be playing. It should pause itself, right? So what I did is I just wrote a little Intersection Observer that said, whenever any of the videos are coming into view, play them. And whenever any video leaves the view, pause them. Pretty simple. So let's look at some code. Let's see how it actually works. First thing you want to do is create some options. So you want to give it a root. By default, the root will be your viewport. But if you have like another scrolling box, a sidebar, something else that needs to be scrolled, you can give it a secondary root. You can give it a margin if you need to do some offset. And then this is kind of the important part, is you can specify thresholds. When do you want to be alerted for these items of when they're scrolled into and out of view? So here what I'm doing is I'm saying, alert me when an item is scrolled into view, alert me when an item is scrolled halfway on the page, and then alert me when a item is fully scrolled onto the page. So as soon as it breaks that, or sorry, 0 would be when it scrolls off, half would be when it's halfway on the page, and 1 would be when it's totally on the page. Then what you do is you create an empty observer. So you say new intersection observer, you give it a callback and the options that we talked about. And then in the callback, it looks a little something like this. The callback is going to be the function that runs when one of your elements trip that one of those thresholds that we said. So one of them leaves the page, one of them is halfway on the page, or one of them is fully on the page. And then what it will do is it gives you an array or a node list of elements that you're watching, and you can check each of those elements to see if it's intersecting. That will be a Boolean. And then it will also tell you how much of it is on the page. So in this case, I'm checking if the entry is fully on the page by checking if it is greater or equal to 1. And if that's the case, I add a class of visible. If it is not the case, I remove the class of visible, and then it's just a CSS issue from there on out. You can add all of your animations and your transitions through CSS. And there's also the ability to unobserve. So if I wanted those, earlier I had those pigs that were swooshing in from the side. If I wanted to not animate them out, I could unobserve that element, and then it would just stay on the page. It wouldn't go in and out as I scrolled up and down. Finally, you go ahead and observe away. So we created that intersection observer. We said when we wanted to watch it, and we said what the options are, what to happen when you watch it. But now we simply just select something to watch. In this case, I selected a div with a class of box, or anything with a class of box, and then loop over that node list and observe each of them. So you can add any element you want, h1, div, images, video tags, to the observer, and it will alert you when those items are being observed. This is just a little kind of an idea of the data that you're going to get. So it'll tell you how the width and the height, the x and the y of the element that you're watching. It'll tell you when it happened. So if you do want to do any animations with timing there, you totally can. It gives you the intersection ratio as well. So next up we have something called Payment Request API, which I'm super excited about because I sell things online. So how many of you have ever coded a checkout form in your life? So probably about half of you. Every single online store that we have needs to reinvent the checkout form, right? Everybody builds their own form tag and the inputs in there. And we have things like Google Chrome has autofill in it, and you hopefully can guess that if it has like a name of first name, then it will autofill your first name, and it works pretty good. But we're all really just trying to do the same thing. We're just trying to collect payment and shipping information from our users so that we can charge their card and send them goods, right? So the Payment Request API is a standardized browser API to collect billing and shipping information from your users. So, whoa, oh no, I hit too many, I'm ruining my, there we go. So here's what it looks like. This is what it looks like on Google Chrome, where you hit the Take My Money API. Let me rewind this sucker. No, we're just going to have to wait for it to start again. Get ready, here it comes. Yes, so we got a button, Take My Money. It pops open the native browser API. You can select from your credit cards on file, select your billing address as well, click Done, and when you click Pay, then you put in the CVC for your credit card, and you can go ahead and confirm. At that point, it will just give the developer your access to the credit card and any of the information that you have collected in there. So you get the credit card number and the billing address, and then you take that data and you still send it to your existing payment gateway, whether you're using Stripe or Authorize.net or whatever it looks like. So here's another example. This is what it looks like on Android for Chrome Mobile, where it will pop it up on there. Here's another quick example where when you try to buy something, it will pop it up. And your card is nicely stored on your phone, so it has access to that, and it's able to pass it off to the developer of that website. Apple Pay is actually built on this same idea. Like everything Apple does, they don't do it exactly to the spec. So it's likely that you'll use some sort of wrapper API so that you can use Payment Request and Apple Pay all in one go, which is really exciting. And so when I show people this, the questions I get is like, does the browser charge your card? And at the very basic, this is glorified autofill, meaning that instead of having input boxes for your user in asking for their credit card data and their billing information. You just ask the browser for it, and the browser will pass it to you in a standardized format. So that's at the very basic. But then you start saying, like, well, is that really secure? But the answer to that is, well, you're requesting the user's credit card in an input box or via this. You get the credit card number at the end of the day. But that said, that's still not always that secure because, like, how many of you have bought stuff off of shady websites on the internet and had your credit card stolen? No one? Okay, only I do. But it's actually going to get even better because in the case of Android Pay or Google Pay and Apple Pay, they don't actually just give your credit card number to the developer. They give them what's called an Apple Pay token or Android Pay token, which is really cool because then your credit card number only stays on your phone, and then you get a token, and then the developer takes that Apple Pay token and goes to somewhere that supports Apple Pay, like Stripe or Braintree, and says, like, hi, I have a Apple Pay token. I was told I could get some money for this. And then you give the token to Stripe, and Stripe will be like, why, yes, we can charge that thing, and it will come and actually give you the money. And that's great, because then you have these one-time use tokens, and if anyone ever get a hold of those tokens, it doesn't matter, because they can only be used once, and there's like a time limit on them, and there's no way for a malicious website to actually get your credit card data and to ruin all of your other credit card data. I know when my credit card gets stolen, I have to go and spend a whole day updating all of my online payments. So pretty exciting. At a very basic, it will give your credit card data to the website, but ideally, looking forward, we're going to go with this sort of tokenization method. Now, let's talk about Getusermedia. Getusermedia is not new at all. I wrote a blog post in September 2011 about this, where it came out in Opera. Remember, Opera was a browser before they merged with Chrome. Opera used to be its own browser, and they were the first people to implement this. And I was really excited about it. And they built this thing that would detect your face via the webcam, and then it would put sunglasses and a funny nose on you, and it would follow your head around. And it was really exciting for the time. And now Snapchat has it, and everyone's like, well, that's not a big deal. But that was using Getusermedia. It allows you to access your user's webcam and your user's microphone so that you can stream that data directly into your browser. But Safari doesn't give a shit, like most things that Apple does. They don't care. And it was like a long 7 or 8 years before it didn't work on the iPhone. You couldn't access your user's camera from the browser. And a couple of years ago, they allowed you to do input type equals file, and you could take a photo and then upload the photo, but there was no real-time stream of your user's camera into a proper HTML, CSS, JavaScript website. Until now, September 2017, so maybe 6 months ago, we got 2 important APIs. First, plays in line. And plays in line is really great because that allows you to not be kicked off to that separate iOS player. You know, when you're watching a video on a website, and you kind of want to play the video but also read the text on the website at the same time, and then it kicks you off to this black player, and you sort of sit on your hands until the video is done. You don't need that anymore because you can add the attribute plays in line to your video tag, and that will allow you to play the video while you're still on the website rather than kicking it off to the full screen experience. So that's good. And then second, we got Getusermedia, which allows you to access both the audio and the video of your user's device. So this is a quick little thing that I cooked up where what you can do is you can access it. Up here is a video tag where I'm piping it in straight off the camera. And then what you can do is you can then take a frame from that video, dump it into a canvas element, and then take that canvas and dump it into a proper JPEG, PNG, whatever format it is that you're looking for. So you can build a full photo booth. I've even done, Chrome now has face detection built right into it, so you don't even need any external libraries, which is pretty cool. It's all promise-based, which is really exciting. So you just say const stream equals await navigator.mediadevices.getUserMedia. You ask for video or audio. So if you don't need audio, it's unnecessary. And then you simply just take a video tag, set the source object to be a stream, and that's it. a couple lines of code, and you're piping in video from your user's webcam directly into an HTML5 video element. Here's just some quick code of how the actual taking of the photo works, where you create an empty canvas element, and you take a frame from that video, dump it into a canvas element, and then you can convert that canvas element into a base64 data URL, and then allow the user to actually download and save the photos to their file system. You can't write directly to a file system, because that would be scary, but you can allow them to click them with the download attribute, and it will download to their downloads folder, which is pretty cool. Actually, there's even some new APIs I saw just a couple weeks ago where this whole canvas in the middle step will be unnecessary. You'll be able to go straight from video tag to image tag without the canvas in the middle. What do we got here? 9 minutes? We're doing great. Next one is Resize Observer. And this is sort of per element resize events. Here's a good example where, similar to when we did the intersection observer, I asked, how do you know when an element is on the page? And you had to loop through every element and check if it changed. Same thing happens with, how do you know when an element is resized? And right now, you have to listen for the window to be resized. And when that happens, you have to check all of your elements and see if they were different than the size they were before. And that kind of sucks, because it's not very performant, checking every element and listening for window resized elements. So just like intersection observer was who would know if an element is on the page or not? The browser knows if elements are on the page or not, because the browser has to paint them to the browser. So same thing with resizing elements. How do you know when an element is resized? Well, the browser knows that, because it has to resize all the different elements on it. So it works exactly the same way as intersection observer, where you have a callback where it gives you all of the entries, and then you can take that and it'll give you the size, the width and the height, the x and the y of each of those, and it will just alert you when that element has been resized, and you can add in your elements. So this is really exciting because it's sort of a gateway drug to element queries in CSS. Right now we only have media queries, which is when your viewport changes. But what if you are, we're all stoked on this component design where if you build a component and it's 1,000 pixels wide, it should look a little bit different than if you build a component and it's 500 pixels wide. Now, that doesn't necessarily depend on how wide your viewport is. It depends on where it is in your application, right? So it's kind of hard to design things based on viewport when you really care about how big is this component where it's living currently. And that's what element queries are going to be. And hopefully we won't need JavaScript for it at all. Hopefully it will just be a CSS thing. But for now, you can use Resize Observer, where we watch for all of our video. Let me show you the example of how this works, and then we'll go back to the code so you can visualize it. So here what I'm doing is I have a video player, and I'm not resizing the viewport at all. I'm resizing the size of the video. And by doing that, the video list on the right-hand side, it itself is getting resized because it's being squished bigger and smaller. So what I'm doing here is, as it gets smaller, I'm adding different classes to that element, and then you apply different CSS depending on if it's small, medium, or large, right? So let's flip back to the code and see exactly how that works. You take all of the entries that come in. In this case, I'm just taking the first entry because I'm only watching one element. And you say if the width is greater than 400, it's large. If it's greater than 300, it's medium, and otherwise it's considered small. You remove all these classes, you add the specific one on that you wanted, and then at that point, this is my favorite kind of JavaScript, where it's just a couple lines of JavaScript, and then the rest of it happens in your CSS. It will add and remove the classes for you, and we get this nice kind of element query for a video as it gets bigger and smaller. So that is some pretty cool stuff. I'm really excited about all this new stuff that's coming to the browser. But of course, there's always the cool Wes, but I actually have a job and I need to support all these browsers, and we're not part of the cool crew that does Chrome Canary and all the flags turned on, right? What about support? So async await is through Babel, so you can compile it back to callbacks or just back to promise-based, depending on what browsers you're supporting. It's totally in Node. It's been in Node for about 6 months now, and it's in all the browsers. So if you are supporting older browsers, not an issue at all, because async await is just syntax at the end of the day. There's no reason why you can't be using it, because I'd say almost everyone is compiling their JavaScript these days. Anyways, Resize Observer is polyfillable, but it's expensive because you have to like run a timeout and check if your elements have been resized every so often. So that's not a great way to do it because you can get some performance hit there. Intersection Observer has an official W3 polyfill, which is exciting. It's up on GitHub. It's pretty small. Web payments is easily polyfillable. You just fall back to a regular checkout form, which is great. Even like if you use Stripe checkout, they have this already built in, where it will try to use the new API. If not, it will fall back to the previous one. Getusermedia is everywhere. Finally, after 9 years of waiting, it's in every single browser. So no sweat there. You can go ahead and start accessing your user's webcam with permission. Of course, one thing I didn't show is that it will pop up a thing and say, can you access the webcam? And you can't just spy on all of your users. That would be crazy. So that's all the support that we have today. I'm really excited about it. Hopefully that you can try 1 or 2 of these things. I do have a couple minutes, so I'm happy to take any questions about stuff. Yeah? Yeah, the slides will be, I'll tweet them out. It's at Wes Bos, and yeah, you can link it, because there's lots of code examples in there that'll be tasty. Thank you. Anyone else? Yeah?
I have an experience with the Intersection Observer. We used it for a site very blatantly. What we found is that it doesn't, unlike something like StickyKit or Wix, where I can sort of tell you almost an exact pixel. We saw that Intersection Observer was mostly a decimal. So, you know, not necessarily perfect.
Oh, it's not as precise as you wanted.
No, and realistically, it's not a huge issue because you can't time how fast you control and know exactly what you're doing.
Yeah.
But we did see edge cases where, because it was 0.9, when it fired, or when we asked it to fire, it was fired.
Yeah.
And at the time, Safari had a really fun bug where it would essentially do parallax scrolling, but no way you ever wanted to do it.
Oh, interesting. So he's saying that there was some performance hit on the Intersection Observer. So I think with anything, those things will probably be ironed out as it's very new.
It was in December.
It was in December, so maybe fixed by now, maybe not. Definitely something you want to play around with before you choose to do a project on it. Cool. Anyone else? Awesome. Well, thanks so much. I'll be around later.